In this video, we're going to take the kind of theory we talked about in the last video and actually show you how to use it. So first, we're going to start off with just printing hello world like we've already done, right? And so for that, when we run it, we'll get hello world just like we expect. Okay? Then we're going to start looking at some other input stuff. First, let's look at what a string. When we talked before, we talked about arguments to a function. Well, hello world, the string would be an argument to a function. Notice here, we just print hello world. But if we add in /n, and we run it, first we can save it, run it, we'll get hello in 2 blank lines because we're using escape characters. These escape characters tell the program to add a new line each time it sees one. Let's actually try using a tab character now too. So here we put in a couple tabs, save it again, and we're going to run it, and we will see something a little different. We will now see our tabs in there. Okay? From here, let's move on to talk about comments. It's actually short here. You can insert a comment anywhere with a $, but anything to the right of the $, is considered a comment. Comment is just a note. And like we said, with every program, we want to insert our header, which I demoed in the Getting Started video, but here would be, this is a program to demonstrate printing. Now, if we run it, you'll notice there's nothing different. Why? Because comments don't do anything. Okay? So from there, we're going to start talking about variables. A variable is a storage spot. It's a way to store a value for later use. So, in Python, all you have to do is say number equals 22. So now, we got rid of this and we said print first number, no quotes, it'll print 22. Here we'll print 22. Now, if we say print first number, it won't print 22. It'll print the string first number because it's in quotes. Here, we'll see first number. Now, we could also print more than one value. Now we print the string first number followed by first number. And here we go. Now we're getting first number 22 like we expected. Okay? So, what else can we do with variables? Well, you can use variables in other expressions. We could say second number equals first number is 5. Oops, forget that semicolon. And now here we could say first number, and then we'll say print second number is kind of a label, second number. All right. So now, when we save it and run it, we will get first number 22, second number 110. Okay? You can also refer to a variable in its own calculations. So now here we can say first number equals first number plus 1. What that'll do is it'll take the 22 in first number and put it here, add 1, and then put it in here. So now when we print it, we'll get 22, but first number here won't change because it's still 22 at this point. So now when we run it, we should get 23 and still 110. And we got a syntax error. And it's because first number. So now we get 23 and 110 like we expected, and now we've seen our first syntax error. Now we're going to move on and talk a little bit more about things like literals and data types. So, for example, data types are what categorize values in memory. And here's an example. We can have an integer value, right? And so now if we print, let's get rid of this. Let's call this int sample. And we can print int sample, and then we'll print the actual variable, right? And if we run it, we will see a simple number. this output and Here we go. In sample, we put a 10. So what if we did this instead? What if we said that we want to say float sample equals 10.001, and then we want to print. Sorry, I can't type today. Float sample. Okay. And now we'll save this guy and we'll run it. Oh, I didn't save it first. Try it again. And it prints out the float sample with the right value. Okay. So now we have to notice that these are different depending on data type. All right. So now we could, in theory, reassign this value. We could say int sample equals float sample. And then if we wanted to reprint int sample after this, what do we get? Notice that it implicitly converted our integer sample to a different type. So that's potentially dangerous because you can even do things like this. String, we can say int sample equals hello. So if we reassign it like this, and then we go to print it, and we go to print it, and we hit run, you'll see it does print hello. It changed the type. But since we originally started off an integer, here's what we can't do anymore. Let's clear this guy out. Run him again. Notice here we get an error because we convert it to a string first, and you can't add a string to an integer. But if we took out this part, okay, and then we saved it, it will work this time because we can take a float, which is what's now in there, and add an integer to it. Okay, so that's the long and short of that. So basically, don't do that. You can keep, cast between numeric types, but don't change an integer variable to a string. It's not the best idea. If we want to read a number from we've talked so far about output. If we want to read something from the keyboard, we can use the input function. The input function always returns a string. So if we say, name equals input, okay, and we can give it a prompt, enter your name, right, and then we can say print name and see what we get. Enter your name, say Larry. Box. Now, you're going to notice that when you run it, it won't let you input anything. So what you're going to need to do is come over here to where it says extensions, right? And you're going to find one called Code Runner. click on this. Click on this little sprocket to configure it. Extension settings. And then what we're going to do is we're going to come down here till we find Run in Terminal. And if this is off, turn it on. Okay? And that will solve that problem. So now, we come back here, and we run it. Now it'll ask you for a value. Say hello, and it'll print out hello. Okay? Got it? So now, the next question is, now that we can input a value, how do we input a number? Well, one way we can do it, let's get rid of some of this garbage code here, is input a value. And then what we could do afterwards is print int value, convert it to an int. Okay. And let's give that a try. Run it. 5. And it worked. So what we should be able to do here is say int value plus 5, because it's converting it to an integer. Okay, so 5. Oops. And it prints 10 because it converted an integer. But what if this happens? Okay. Enter your value. We'll put hello. And we get an error because it can't convert it. But, so, to sum it up, if you want to read an integer, the easiest way to do it would be int val equals input int input enter an integer. And this will let us enter an integer and convert it for us. Now, the one thing, again, is this doesn't check to see if it's a properly formed integer. Later on, we can learn how to do that. But for now, let's get rid of this. We can save it and run it. And now we say, enter an integer, 25. Sorry, a little sloppy there with the thing. 25, and it worked. So now, taking us to the next step, we can do the same thing with a float. Now I cut and paste because it's quicker, but we'll fix it up. We'll say float. We'll say enter a float. Okay, and now we'll print out that float value. Now we can run it, and when we run it, we'll get, first it'll ask an integer, we'll say 5, and then we'll enter a float, which will be 12.123, and there we go. So, and then technically speaking, we could convert to a string by saying print float, and that will make it into a string. So now we run it. We can say 5, and we can say 12.2, and we'll print it both times. Oops, I didn't save it. Run it. 5. Whoop, and 5. 12.222. And it prints it twice, but the second time it prints it is a string. Okay. So, given that, we now have some basic functionality. let's go into performing some calculations. Okay, so we have math operators, which allow us to do simple, or to do rather complex arithmetic. Let's take a look at a few. Okay, so let's say we've got add example, or left value equals 5, and right value equals 8. And then we can say sum equals left value plus right value. And then we can output print left value, comma, plus, comma, right value, comma, equals sum. Now there's a much better way to do this, but we haven't got there yet. But if we run this, we can say 5 plus 8 equals 13. So now we can say difference equals left value minus right value. And then what we can do is come over here and say print left value minus right value equals difference. Save it. Now if we run it, we will see this and we will see this, and it works. We can now, if we wanted to, we can come back and say left value equals left value plus 15. Right? So now if we print left value equals left value, we will see 20. Again, left value equals 20, and now we could then go on and say difference equals difference, current value, plus left value. And now let's output the difference. Print difference. See what we get. And difference equals 17. And if we look, that makes sense. Left value being 20 minus negative 3 is 17, or plus negative 3 is 17. So, other operations. We have integer division. Okay, so here we say print 3 divided by 5, or we can put it in the variable int div equals 3 divided by 5. Okay, and we can say and now if we run it, we will get, let's save it, we'll run it. Now, because, I'm sorry, that's not integer division, that's floating division. Okay, but now, if we use this instead, sorry, we'll get integer division. And this time, 3 divided by 5 is 0. But since we've done that, we can now say, what if we said in modulus division equals 3 mod 5. And now, for that, it should print 3. Okay. Or if we say 10 mod 3, it should print 1. Got it? So that is that. We also have an exponent operator. We can say print 2, 8, 2 to the 8th, save it, and let's run it, and then we get 256, and that comes up with those operators. Now, we can talk a little bit about converting math statements to programming. So we've got 2f 5 plus 2. In code, we would have to write this, say x equal. We would have to write this as x equals 2 times f times 5 plus 2. Okay? And we have to define f equals 2. Okay? And therefore, so we basically have to have symbols for everything. All right? Now, for order of precedence, if we say we've got, print 3 plus 5 times 2, we would get 13. But if we say, now another thing that we talked about is continuation of lines. We can say result equals R1 times, let's see, right value plus left value times, and then we could say slash as the continue character, and then we would say difference, and then we can print out our result. Save. And there we go. Now, this is a little cleaner to read, but there is a better way, an easier way to do this, is you could also just use any parentheses. And if we said result equals right value plus left value, we can get rid of this and even do something like this. And now if we save it, it works again. Now, this is kind of nicer because we don't have that weird thing that doesn't seem to make sense, that extra slash. Now, we can also do this with any function that has parentheses. So if we say print A, right, B, C, save it and run it, that will work too. And now, the way you can add two strings together. Let's say we had string 2 equals fun language. And then we could say string 3 equals string 1 plus string 2. And then we could print out a couple things. We say print string 3. And if we do that, that should give us, this is a fun language. We could also say print string 1 plus crazy world. Okay. We could then run this guy and I'll say this is a crazy world. We could also, what if we did this? What do you think was going to happen? We get an error. But we could do this. Okay? So that's how we print. Now, another thing we could do is you could say, if you wanted to say string A plus string B plus B plus C, we could instead just say this. And it'll do the same thing, but I don't like it. I don't think it's nearly so clear, so I wouldn't do that. Just my opinion. Okay? So there are some basic things. And that's called literal concatenation. So now we're going to talk some more about the print function. Currently, whenever we do print, it prints a new line. Okay? Which can be kind of funky if you want to do something like print multiple things on a line. So what we could do is say print, name, and then we can say sep or end equals space. Okay, let's delete all this. Okay, and now if we run it, boom, name, but there's not, it didn't throw a new line. So now if we did another print right after it, we could say age. And we ran it. We get name and age because there's no new line. Now if we print height and we run it, height's on a separate line because we didn't change the limiter. Similarly, we can, when we print three things, like print 1, 2, 3, and we run this, what it will print is those numbers separated by a space. But if we wanted to make them separated by a comma, we can say sep equals comma and run it. And now they're nicely separated by commas, or we could say separated by a new line. And there we go. Okay, so it's pretty versatile. Now, when we print variables, one way to print them would be, let's say, x equals hello. Okay, one way to print them would be print in a sentence, to be like print, hi there, x, how are you, right? And if we print this, we get, hi there, how are you? Hi there, hello, how are you? But there's an easier way. We can use what's called an F string. And an F string is a special type of string that is a fillable string. Okay, so what we can say there, hi there, And then if we put an F in front of it, we've now created an F string. Hi there. And then whenever we want to replace a string with a variable, we can say X. And when it sees the squigglies and the X, it will replace the curly brackets and what's inside of it with the value of X. And we can say, how are you? And we'll get the same results, but it's cleaner. Okay, there you go. And where this is really useful is, let's say, A equals 5, B equals 7. And sum equals A plus B. And then what we could say is print F A plus B equals sum. And what that will do is come through this string and replace each of these templated values, that's what this is called, a template, with the contents of A, the contents of B, and the contents of sum. Okay. It's an easy way to combine types. So now, 5 plus 7 equals 12, and boom, there we go. It's a pretty powerful technique. Okay, so now, what if we have all this and we want to clean it up a little bit? Well, I'm going to say num equals 3.14159. 265, right? And we want to round this to 2 decimal places. When we print, we can say print F, and we can use this quote for a difference, and say num, and inside here, inside our template, we can say num, and then we can put a colon, and we'll give it some formatting information, say 2F. That's 0.2 following the floating point. So now if we run it, we get 3.14. Nice, huh? Now what if we want to deal with bigger numbers? We can say, let's rename this to pi. All right, and then we'll say num equals 1,000,000. What we could do here is we could say num 2F comma, we put a comma here, and then when we do that, what we get is this. We get it nicely putting the comma in there, or we could put a space if we wanted, or whatever. And run it. And this time it doesn't do anything. Only the comma will change it. I believe for other cultures, though, it will let you replace it. Anyway, so now we can do another thing. Let's say percent. Percent equals 0.5. And we want to print this out as percent. All we have to do is say F. All right. And then we say percent. That colon, and we say 0.0, meaning we want nothing after there, and then we give it the percent. Okay? Whoop. Now if we run it, what do we get? We get 50%. And if this had said 0.2, we get 50.00%, right? Now, what else we can do? We can specify the type. Okay? We could use, let's go back to our first number here. We say 2F is a 2 floating point number. We could say D, which will make it a decimal. If we run it, it just prints it as a decimal. If we wanted to say, print it in scientific notation with 2 significant digits, we can do this, and now it'll print it in scientific notation. We can also say we want this to take up a minimum of, let's switch to pi now. Take a minimum of, let's get rid of our comma here. We can leave it in, it doesn't matter, because in this case, let's say we want to take up 12 characters, and we want it to print, you don't need a space there. Oh, I'm sorry, I got this backwards. You've got number spaces, you've got the format, like whether you need a comma or not. You got the decimal part, or the float part. And if we run this, we will get pi, but it will take up 12 spaces, okay, for the whole number. That is very nice. And now what we could also do is this. We can do, if we want to left align a number, let's see, so let's get rid of this. And we'll say less than 20, 2f. We'll make it 20 spaces to float. So now if we run it, we get 3 last time, but we float left. So now if we float right, what do we get? Now we get the spaces, or we can say float center. Now if we run it, it will put it in the middle. Okay? So far we've seen these formatters. We've got the centering formatter, which is either this, this, or this. We've got the size afterwards, 20. We've got the type. Okay, and that gives us a lot of control of how to display our numbers using the F format output. Okay. Now, one thing to keep in mind, when we use pi, like we do here, right, I can say this. And that will redefine pi, which isn't something we want to do. So what we can do is use a convention here and make it all caps. Here, all right? Now we run it, same result, but now it still works. So did it help us much? Not so much, but what it did do is it let us define a special formatting. We use all caps to say this is a constant, meaning it's unchanging. Okay? Now, that doesn't mean it can't change, but this is common notation in Python to say it's not going to change. Why is this important? Because here's the thing. Let's say we want to compute the area of a circle. Equals pi times r squared. R equals 12. Okay. Print area of circle with radius r is area. Okay. So now let's run this. And we get what we thought. Area circle is, radius 12 is 452. Now, let's say we want to say circumference. Which is defined as 2 times pi times r. Now, we run this. Let's print circumference. we run this, we will see the desired result. Oops, and I can't apparently type. Let's try it again. It is being temperamental. Now let's run it. And here we go. Circle area and circumference. Now, had we not used constants and we'd used direct variables, here we would have 3.14, 59, 265. And then here we would also have to have, but what if I mistype this? Now we don't have consistent values. So instead, what we'd rather do is define it up here once as a constant. And that way we don't have magic numbers sitting out there. And if we have thousands of files, this would become even much more harder to debug because you have to change it every single place. All right? So that's that. And so that sums up our introduction to variables, input, and output. So let's write a little program really quick. Let's say we want to convert to calculate the area of a rectangle. Okay, so first let's put in a nice little, well first, before we do that, is follow our rules. We're going to put in our header. Okay, see? That's nice. All right, so now let's write a program to get the area to compute the area of a rectangle after receiving the width and height from user input. So first we need to do is we're going to say width equals int input. All right, and we want to say enter the width of your rectangle, and then we'll have another one, height, and we want to make this a float, not a int. Enter the height of your rectangle, and then what we want to do is print given, oops, we'll make an F string, given a height of height given a width width, and we want to limit this to 2 decimal places. The height of height, that's 2 decimal places. Then the area is area. Now notice I didn't have area. But here let's define the area equals width times height, right? And now if we run this guy, we can enter this 5.1, 51.1, who cares, and 12.2, and there is our area. So that is an overview of all the stuff we talked about in our last video and how to write code for it. Happy coding!